All right, so here's example 2. We're going to understand the end behavior of polynomial functions. Now this is crucial to graph, understanding the end behavior. So the question, how do the sign of the leading coefficient and the degree of a polynomial affect the end behavior of the graph of a polynomial function? Well, let's go ahead and take a look. We have 4 different cases here that we're going to look at. Odd degree, positive leading coefficient. Even degree, positive leading coefficient. Odd degree, negative leading coefficient. And even degree, negative leading coefficient. So in this first case, odd degree, positive leading coefficient, you'll notice each of these functions, f of x, g of x, h of x, correspond to the graphs down here. So f of x equals x, the exponent's a 1, so the degree is 1. For the g of x function, the leading term has an exponent of 3, so the degree is 3. H of x, the exponent's 5, so it has a degree of 5. And then, of course, each of these polynomials has a positive leading coefficient. So this one's 1, this one's 0.5, and this one's 2. So as we look at the graphs, right, the characteristic of each of these graphs is that they all drop down to the left and they rise up to the right. Another way to think of that is that as x increases, right, the function increases, or the y value increases. All right, case number 2 is when we have an even degree positive leading coefficient. So you'll notice for each of these functions, the degree, right, is even. So this function has a degree of 2, this function has a degree of 4, this function h of x has a degree of 6. And then you'll also notice that each of the leading coefficients is positive, right? So when we have an even degree and a positive leading coefficient for our polynomials, the effect of that on the graph will be that the graphs will rise to the left and they will rise to the right, right? So in other words, the function increases, or the y increases as x increases, and the function or the y increases as the x decreases as well. All right, let's look at the third case, odd degree negative leading coefficient. You'll notice that the degree of each of these functions is odd, right? This one's 1, 3, 5. And then the leading coefficient for each of these polynomials is negative. So this is negative 1, negative 0.5, and negative 2 for our leading coefficients. So what do the characteristics of an odd degree negative leading coefficient polynomial give us? Well, we have, it rises to the left. You'll notice it rises to the left, each of these, right? And they drop down to the right. So. And finally, our fourth case is even degree negative leading coefficient. So each of these has an even degree, 2, 4, and 6, and it has a negative leading coefficient. So you'll notice that they drop down to the left and to the right. Each of the graphs looks a little bit different, but they have the same overall effect.